All right, welcome, welcome, welcome. For your Ed puzzle today, we're going to go through and do a few examples, and I'm going to ask you um, to make some conjectures, some educated guesses about what things are, and then when we get done, we're going to do a little bit of IXL, and at that point, you can choose whether you wouldn't want to work on that independently, or maybe if you want to get a little help from a teacher. Okay, so today what we are doing is something called the distribution property. And what it is, it's another way to write multiplying, essentially. And if you notice in this first example, we're talking about groups. And when we're talking about groups, a lot of times we're talking about multiplying. Because if I said I had two groups of 5 things, well, that means I'd have 10 things. That'd be 2 times 5, right? Well, now we're doing the same thing, but with algebraic expressions. So I've got 2 groups, and in each of these groups, there's going to be 2 positive x's and 3 negative 1's. Up there in the upper right-hand corner of your screen, I kind of have the key so you remember what shapes go with what algebraic terms. And so if I wanted to draw this, it would look like that. I have 2 groups, and each group has 2 positive x's and 3 negative 1's. So your first question, if I was going to look at just one of those groups, okay, the one I circled, how would you write the algebraic expression for that? All right, if you said 2x minus 3, you are correct because I've got 2 positive x's there and 3 negative 1's. You could have also said 2x plus negative 3. That means the same thing, but usually when we're writing a simplified expression, we're going to write minus 3. But if you wrote plus negative 3, that's fine too. Now, what if I took these 2 expressions and I put them together? So I take both of those, I add them up. What would be my simplified algebraic expression? And remember, that is, what do you get when you combine those 2 things and you combine all like terms? Awesome. I'm sure everyone got that right. The correct answer is 4x minus 6. Okay. It would be the same if you said 4x plus negative 6. That is correct. We just would prefer that you write the final answer without any brackets. But a lot of times it does help people to write them as addition problems. And that's something we're going to do on a few future examples. All right, let's take a look at the next one. Now this one I've already got drawn for you. You have 3 groups, and in each group there are 2 negative x squareds and 5 positive 1's. If we combined or added all of these groups together, what would be the simplified algebraic expression? So take a moment and see if you can come up with that. All right, if you got negative 9x squared plus 15, you nailed it. And how we did that, you could just count all of the squares. And in that first group, you see there's 3 negative x squareds. I use the shaded picture because they're negatives, and 5 positive 1's. And then there's the second group and the third group. So when you combine all of those like terms, that gives me the x squareds and the 1's. All right, so this is great, but we don't always want to have to draw out algebraic models because the numbers get really big. We start working with fractions and decimals, and it's just too time consuming. So it's a good place to start. But what we want is a few strategies where we won't have to draw them. Okay, so that's what we're going to talk about right now. So the first one, and this is where we get into what's called the distribution property. There's 2 methods I'm going to look at here. The first one is what I call the rainbow method. Okay. Now, the reason I call it the rainbow method is because when you are multiplying, like in this case, we have 4 groups of 2x plus 5. And I've got the picture of it right there. And you might be able to go ahead and actually take a moment and write down what do you think the simplified algebraic expression is for this? All right, we'll see if you got it right. What you would do is you would go through, and I'm going to take 4 groups of 2x and 4 groups of 5. Okay, the reason it's called a rainbow method is you can kind of imagine those arrows as little rainbows. So if I've got 4 groups of 2x's, so that's like 2x plus 2x plus 2x plus 2x. And you can see that over there in the picture. Altogether, I've got 8 x's. And then I've got 4 groups of 5. So I could do 5 plus 5 plus 5 plus 5, or I could just do multiplication. That's why we have multiplication. And 4 times 5 is 20. So the correct answer is 8x plus 20. All right, that's what the rainbow method is called. Like, it's because I'm using those little lines there to show what is being multiplied. I wouldn't actually draw it out. The other method It's called the area model. And a lot of you probably have learned this back in elementary school when you did multiplication. Okay, as a little refresher, let's say I wanted to do 62 times 415. Well, 62, I would break down into the numbers 60 and 2. And then 415, I would break up and do 400, 10, and 5. And what I'm doing is I'm essentially finding the area for each of those rectangles. Like in that first rectangle, if one side was 60 and the other side was 400, 60 times 400 is 2,400. Okay? What would go in the next box? All right, if you said 600, you got it. And then in the rest of them, 300, 800, and so on. And at the end, you add all of those things together. Right? It works just the same in algebra. So if I wanted to do 4 times 2x plus 5, I'd put 4 on one side, I'd put the 2x and the 5 on the other, and then I would find the areas. So the first box would have an area of 8x. The second box would have an area of 20. So my correct simplified algebraic expression would be 8x plus 20. Okay, same thing as when we did the rainbow, using the rainbows. It's just a different way to kind of represent it visually. All right, so take a moment, write down what you think the correct simplified expression is for 2 times negative 3x minus 10. All right, and these questions, sometimes it's easier to write them as addition problems. Okay, if I did that, okay, there's what the picture looks like. 2 times negative 3x, or 2 groups of negative 3x, would give me negative 6x. 2 groups of negative 10 be 2 times negative 10, which is negative 20. So that is the correct answer. But again, when we write our final answer, it's a little better to write it without parentheses. And so the best way to express this final answer would be negative 6x minus 20. So that's what the rainbow method would look like. Using the area model, you might already guess this. You could leave it as a subtraction problem, or you could turn it to an addition problem. You'd have the 2 and minus 3x minus 10 on the outside. Then I would find the areas by multiplication. And then the last thing is you would combine those to give me negative 6x plus negative 20, or like we said, we could write that as negative 6x minus 20. All right, let's look at one or two others. Okay? What if I took that 2 and made it a negative? Okay? You're going to be encountering problems like this. Everything works pretty much the same. Okay, you could, again, put it into an addition problem if you want, but on the outside, you'd have the negative 2, and then on the top, you'd have negative 3x and minus 10. And now you just need to remember your rules with negative numbers. Okay, a negative times a negative is a positive. Okay, same thing in the second square. So by making that a negative 2 in the front, my final simplified expression would be 6x plus 20. All right, one last one. What if I took this similar model? Okay, there's the picture of it. That's the one we started with. Let's say I put a 5 plus that in the front. What do you think the answer would be? All right, let's see if you got it right. Well, on this one, remember, if I added 5 positive ones, I just put those little 5 squares in the right-hand corner because I'm going to combine that with everything that I've already got. Okay, well, when you go through, this is how we solved it without using the rainbow method without the 5 there. Okay? Well, what happens when I put the 5 in? Okay? Well, that doesn't change the grouping. I still have 2 groups of negative 3x minus 10. So when I'm going through and doing my algebra, I just have the 5 in the front. It doesn't really affect anything until I get to this step right here. Now, in the last step, let's get rid of that negative 6x minus 20. Okay? When you look at that, what can be combined? Okay? In this case, it's the 2 constants. What do you think the simplified answer for this is? What's the last step? All right, if you said the correct answer is negative 15 minus 6x, you are correct, because 5 plus negative 20 is negative 15. And you could also look at that visually up in the upper right-hand corner. Is there, I've got 5 zero pairs, and those cancel each other out. So what I'm left with is 15 negative 1s. Okay? It doesn't change the negative 6x's. So hopefully that gives you a little information on your distributive property. you are going to be going in and doing a little bit of IXL work. And at that point, if you need some help from your teacher, we are more than happy to assist you.